there is this problem called as silly window syndrome. Silly window syndrome. So silly window syndrome occurs in various cases. One case is like this. Assume that the receiver has advertised that his capacity is 1000 bytes. Receiver advertised that his capacity is 1000 bytes, and in one go the sender has filled it all, or after some few goes, after some few transmissions, the sender has completely filled the 1000 bytes, which means sender has sent many segments, each of some size, and all of them put together they made 1000 bytes, and the entire window is now full. Now what will the receiver advertise? In the window size it will advertise it as 0. So what does that mean? It means that receiver cannot receive any more data, therefore it is your responsibility to decrease your, or it is your responsibility not to send, and get that data will be lost if you send it. So it is now the responsibility of the sender in order to periodically probe it. So for that we are going to use persistent timer. You know about it, right? And after persistent timer it will simply keep on sending 1 byte of data with 20 bytes of header, and it will say, let us say, still in the window size it is saying 0. Then what will you do? Again, after waiting for some time, again you will do the same thing. You will send a packet with 1 byte of data and 20 byte of header, right? And again let us say it is saying still I don't have any capacity, window equal to 0, right? So whenever you send this 1 byte, obviously that byte will be discarded, and in the acknowledgement you will get the acknowledgement number as still this byte is expected. How it works is, let us say already you have sent the byte number still 200, and next time in this one you are sending the sequence number of 201, right? Then the receiver will see this packet, discards it, but then sends back an acknowledgement. On that acknowledgement you can see that window size is 0, but still the acknowledgement number will be 201. Even though you are sending 201 byte, it doesn't have space to receive it, therefore it discards it, and will still say that 201 is expected, therefore that 1 byte is not lost. In case if by the time it goes there, if it has this space, it will read in that 1 byte and then advertise the remaining space back, so that you can send the entire communication. But anyway, if this is going to happen for a long time, which means you are keep on sending this 1 byte, you will keep on sending 1, and it will keep on sending in the advertisement window 0, which means my capacity is 0, and again you send 1, it will send 0. So it is simply called silly window syndrome, which means you are not doing any useful work. You will just send 1 byte, that will be discarded, and they will send 0, 1 0 1 0, like that. It is simply a silly window. Why it is called silly window is because window size is 0, which is silly, isn't it? And sometimes what happens is, so this is when the receiver advertises that its capacity is 0. Sometimes what happens is sender doesn't produce the data fast. So sender will keep on producing only 1 byte at a time, and therefore it will send only 1 byte with 20 bytes of header, or not 1 byte, let us say very small data. So data is very small. Now I'm taking as an example, but it did not be always 1, very small, less than 20 or less than 30 bytes, something less than 100 bytes. So it is sending very small data, like for example 1 byte, and then you are getting the acknowledgement, and again you are sending 1 byte of data, and again you are getting acknowledgement, right? So this problem arises when the sender is producing only less amount of data at every time. This is also one reason for silly window syndrome. One reason for silly window syndrome is when the receiver has announced that its capacity is 0. For some time, if it is keeping on announcing that its capacity is 0, then we are going to send 1 byte of dummy data. That is called silly window syndrome. And the second reason for silly window syndrome is the sender is producing only some few bytes at a time, or 1 byte at a time, sender application. Therefore, transport layer is sending only that 1 byte, right, all the time. Then it is also a reason for silly window syndrome. And the other reason is the receiver is consuming only 1 byte at a time, which means you will send some data, and next time in the advertisement window it will say that my capacity is only 1 byte. Then what is that you are supposed to do? You are supposed to send only 1 byte of data with 20 bytes of header, and let us say again the receiver is consuming only 1 byte, which means it is initially having 1000 bytes of buffer, and 1000 bytes is completely full, and only 1 byte space is remaining, which means 999 is full. then it will keep on sending only 1 byte, and again you will send some data, that 1 byte of packet, and by that time it will consume 1 byte, and again 999 is occupied, and again it will advertise you back advertisement window as 1 byte. Therefore it will keep on happening. So what are the various reasons for silly window syndrome is, one is when the receiver advertises that its capacity is 0, other is when the sender is producing only 1 byte at a time, and the other is when the receiver is consuming only 1 byte at a time, right? So whenever receiver advertises its capacity is 0, eventually after some time, after some amount of time, it is supposed to fix itself. The reason is it is not a problem with the sender or receiver, it is a transient problem, which means for some time the buffer gets full, and after some time receiver will anyways receive the packets and it will clear the buffer and everything will resume normally. It is a transient problem. But when the sender is producing only few amounts of bytes, it is not a transient problem, it is a persistent problem, which means throughout the connection this might keep on happening, and because of which the efficiency is going to degrade a lot. See this, in the entire round trip time we are sending only 1 byte, and in order to send 1 byte we are wasting nearly 80 bytes headers. Why? At transport layer 2 bytes of headers from the sender and the receiver, from this side and this side, and network layer again 20 bytes of headers. So efficiency is going to be very less. So in order to solve this problem, where sender has advertised that sender is producing only 1 byte at a time, in order to solve this we have an algorithm called as Nagel's algorithm. Nagel's. So Nagel's algorithm says that if the sender is very slow, then the transport layer should not send 1 byte of data. The transport layer should wait for 1 RTT, 1 round trip time, which means you send 1 byte of data initially, and by the time that acknowledgement comes back, in this time you see how much data you could buffer, right? So let us say you have to buffer for 1 RTT, and in this 1 RTT time, let us assume that you got 40 bytes or 50 bytes. Then you send these 50 bytes and again wait for 1 RTT. Therefore Nagel's algorithm says that wait for 1 RTT time, round trip time, and in that time see how much data is produced by the application layer. Then you send that data in one segment. Don't send 1 byte each. In case in 1 RTT only 1 byte is generated, obviously we don't have any other choice, we have to send 1 byte. But then most of the cases in 1 RTT more than 1 byte will be generated. And in case if the data generated is greater than MSS, 1 MSS, then you have to send only 1 MSS, which means Nagel's algorithm says this: you wait for some time, how much time? 1 RTT, and in this time whatever data bytes are produced you send it, or sometimes you will be able to fill up one maximum segment in a time less than 1 RTT. So in case if you have a chance or if you get a maximum segment in a time less than 1 RTT, you send it immediately. So how does this algorithm work is, you wait until you fill up one MSS and send it directly. In case if 1 MSS is not received, then how much ever data you got in 1 RTT you send it, right? So let us assume, I'll just take a question and explain you. Let us say an application is producing 1 byte per millisecond, which means application layer is giving 1 byte per millisecond to the transport layer, and now RTT is found out to be 100 milliseconds and maximum segment size is found out to be 200 bytes. Then what should the sender's transport layer do? Then what should sender's transport layer do is, it should wait for 1 RTT. In this 1 RTT, how much is what is 1 RTT? 100 milliseconds, and sender is sending 1 byte per millisecond. Therefore in 1 RTT, how much data can the application layer give to the transport layer? 100 into 1, which is nothing but 100 bytes. Therefore you are going to send 100 bytes of segments each time. In case if MSS is less than 100, if MSS is 50, then whenever we get a chance to fill up 150 byte of data, we'll send it. We'll not wait till RTT. Okay, so Nagel's algorithm is going to work, help us whenever sender is very slow. So generally it used to happen whenever you type some data and the typing speed is very less and the data is coming back. I mean this round trip time is very less, but your typing speed is also very less. Then what should we do is, in this typing speed, in this 1.tt, how many ever bytes you type, all these bytes will be taken by the transport layer and sent at one go. In case if you are very fast in typing, then maybe you will fill up the 1 MSS and 1 MSS will be sent directly, right? And now what about this destination problem? So whenever this destination is saying that destination is consuming 1 byte at a time, then Clark has proposed a solution. Then Clark has proposed a solution that destination should not advertise 1 byte. It should wait until it can send a MSS, at least 1 MSS gets freed there, one maximum segment size gets freed there, or at least half of the buffer. So Clark algorithm says that the receiver should not advertise 1. Whenever it has to advertise 1, it should hold on. It should not send any packet. What it should do is, it should wait until it gets a size of 1 MSS or half the size of the buffer. So that is what Clark algorithm says. Now coming to this, whenever the receiver is saying 0 for a long time, then normally what we do is, we use reset flag and we flush the connection and we restart it again, right? So these are the various reasons why our connection will be slow. One thing is, receiver is advertising its size is 0. Other thing is, sender is sending data at a very slow rate. Other thing is, receiver is consuming the data at a very slow rate. All these are problems. So for every problem we have seen, the solution is there, and one solution is Nagel's, other is Clark, and other is this. Till now nothing has been asked in GATE about this, again because it is not a, all the standard TCPs are not implementing it, but still we covered it, okay.